manipulating equation. Manipulating equations. Okay. So in this case here, you're solving for v. That means that you're gonna isolate vi. So from your equation, if you're gonna solve for that variable, that means that that should be placed in one side of the equation. Okay, so that means that it should be placed either on the left hand side or the right hand side. That means that the only letter that you can see in one side of the equation is your vi. So how do you do that? Well, starting with this one here, this is in parentheses, so you need to work with the parentheses first. So that's multiplication. Is it not that if I'm going to divide this by t over t on both sides, this gives me d over t, and this is cancelled off. So this is vf plus vi over 2. So if I'm going to do that, somehow I now separated my t. Remember that my aim is to isolate vi. So vi, you still have 2 at the bottom here. So I need to get rid of that particular number 2. So how can I get rid of 2? Well, is it not that if you're gonna multiply this by 2, 2 over 2 is just equal to 1. So that canceled off. Again, the general rule in algebra is that whatever you do in one side of the equation, try to do that one also on the other side. So that gives you 2d. 2d over t is equal to vf plus vi. But then again, I need to isolate my vi. So that means only vi on that side of the equation. So I need to get rid of vf. So is it not that if I'm going to subtract this by vf, this gives me 0, or that would be gone in that particular side. But I will also subtract the other side with vf. So if I'm going to subtract 2d over t with vf, that gives me 2d over t minus vf is now equal to vi. So that would be my final answer. I already separated my vi with the other variables. So essentially, if you're solving for that variable, that only means isolating. Or if you want, conventionally, we always try to write our unknown, at least the variable that we are solving, at the left-hand side of the equation. But that is just the same thing as vi is equal to 2d over t. So essentially, I'm not doing anything here, just trying to reverse the placement between your two sides of the equation. I can do that. I can flip them over and it doesn't change. Okay, we can do letter B, solving for m. So we want to solve for m in this case. So that means that I'm gonna isolate my m. So how would I isolate my m? Well, this contains two terms containing m. So the first thing that I'm gonna do here is factor m between these two terms. So if I'm gonna factor out m, so what leaves in my other one would be v squared plus gh. Okay, so if you can see, again, same thing, I want to isolate my m in this case. So how can I isolate m? Is it not that if there's a way that I can get rid of this whole parenthesis thing, well, that means that I already isolated M. So is it not that these two are factors? So M times this whole thing, the operation is just multiplication. Is it not that if I'm gonna divide this by the same exact factor, which is 1/2 v squared plus gh, okay? If I'm gonna divide this side, is it not that this is canceled off or the value is just 1? But then again, as I mentioned earlier, whatever you do in one side of the equation, I will also do that on the other side. That means that I also divide this by the same exact expression. So GH. So if I'm gonna do that, M, again, this exactly any expression divided by the same exact expression is just equivalent to 1. So therefore, this gives me E over 1/2 v squared plus GH is equal to M. And that would be my final answer. So I successfully isolated my M. So I did the factoring first. And then from the common factor, when you do factoring, the operation is just multiplication. So if I'm gonna divide that factor with the same exact factor, the answer is just 1. So essentially, it's just the same thing as canceling that particular term in that side of the equation. And then for letter C, I'll be solving for E. So that means E should be isolated. So if you can see here, I have an operation of a square root symbol. So the square root of 2ek. So that's the first thing that I'm gonna do. I'm gonna take off the square root thing because E is inside that. E is part of the radicand of this radical, on the right-hand side of the equation. So how would I get rid of the square root symbol? If you can remember, square root means this square root thing here is just the same thing as excuse me. So that is just 2e over k. That is just the same thing as the exponent is 1/2, okay? So how would you get rid of that 1/2 exponent? Well, is it not that if I'm taking the square of this essentially get rid of that? Because if you can see in your law of exponents, that is 1/2 raised to the power of 2 is 2 times 1/2. So essentially the answer there is just 2e over k. But that is one side of the equation. The other side, again, whatever you do in one side of the equation, you also do that in the other side. So if I'm gonna take the square, this becomes x squared. So somehow, in that particular case, I was able to get rid of my square root symbol. Now, time to isolate my e. Well, I want to have a value of e, just e, in one side of my equation. So in this case, I'll just gonna place my e in the right-hand side of my equation. So what would I do? Well, I need to get rid of k and 2. So if I'm gonna multiply this one by the reciprocal of that, is it not that it gives me just 1? This whole thing, that's canceled out. However, since that's what I did in one side of my equation, I also do that in the other side. So if you can see, this becomes kx squared over 2 is equal to e. That's your final answer. Okay, are there any question with this one here? Again, that is just manipulating your particular equation. Okay, we can move on to the back page. So this is just on changing from changing into scientific notation. So just remember that the scientific notation is in the form of m times 10 to the power of, I think we use the symbol n for that, wherein m is greater than or equal to 1 but less than 10. So just remember that. So therefore, for the first one, take note, you also have to indicate the correct number of significant digits here. There are 3 significant digits here. So that means that if I can express that one into scientific notation, it should be 8.81. So 3 sig figs also times 10 to the power of positive 4. And the unit is joule. Okay. So take note of the correct exponent, the number of significant digits. So there are 3 things that you need to take note of this one. The correct exponent, the unit, and it should be 3 sig figs. And then for the next one, this contains 2 sig figs. So that means that my final answer here in scientific notation also, that should also have 2 sig figs. Times 10 to the power of, if you can see here, you're dealing with a small number, a number that is less than 1. So therefore, the exponent should be negative. So negative, what would be the exponent? Negative 1, 2, 3, 4, 5, 6. So that's negative 6. And then the unit should be Newton. And letter C has 2 significant figures also. So that would be 2.3, and then times 10 to the power of, that should be to the power of 2. And then it's seconds. Okay. So now, this is changing scientific notation into expanded form. Okay. So common form or the standard form of a number. So again, take note of the correct significant digits here. So you're gonna place all of this in your expanded form also. So this is times 10 to the power of 4. So that would be 3, 2, 1, and then 0, I think 0, 1, 2, 3, 4. Okay. That would be liters. And then for letter B, it's negative 3. So that would be 0.0. So since that is a negative exponent, I'm expecting a number, a decimal number, because the exponent is negative. So 0, 0, 8, yep, 843 kilogram. And then for the last one, this has 5 significant digits to the power of 2. This is 170.01 second. Okay. So that should be the answer. So expanded form, again, you just try to do the reverse. Again, the exponent tells you if you're dealing with a big number or small number. Positive exponent, that means that you're dealing with a big number. A negative exponent, again, you now have an idea that your answer should be less than 1 or a decimal number. So try to take note of that.